Hello folks, welcome to magnetism or magnetic field lecture 3. So today I'm going to deal with this topic. So we have to determine the direction of Lorentz forces on a conductor under different conditions. Last time we had an understanding of one fact. It is that when a current carrying conductor is placed in a magnetic field, uniform magnetic field created by any source, it feels a force, and the direction of the force is given by this left hand rule of Fleming. The force is called Lorentz force, and the direction is given by Fleming's left hand rule. And I stated that if the direction of the magnetic field is represented by the index finger, and if the positive current in the wire is represented by this middle finger plus others, middle finger only or plus others, then the direction of the thumb gives the direction of force generated, Lorentz force generated. So now we will do this thing. We will do this thing for several cases, every possible cases. So let's see. So in the first case, I have got magnetic field like this. So this is north pole of a magnet. This is south pole of a magnet, and our conductor is like this. This is the conductor in which current is going in that direction. So if so, the magnetic field will be like this. So it goes from N to S. It will be like this. This is the direction of the magnetic field. Then the current is going away from us in that direction. So it should be like this. So my fingers are over there. Middle finger is over there. So if I do this, it is in this direction. If I do this, it will be in that direction. So magnetic field in this direction, and this fingers are in that direction, and the force is here. So see the thumb here, so the force is here. So this gives us the direction of the force. So let me use a red pen to show the direction of the force generated. Now in the other case, if I reverse the direction of current, so this is north pole of the magnet, this is the south pole of the magnet, and what I do now is, let me reverse the direction of the current. So the dot circle means that the current is coming in this direction. So let's go for the force here. So the force is like this. I have the magnetic field is like this, N to S. The conductor is carrying current in this direction. It is coming towards us, dot circle. So that means the force should be in upward direction. So this gives the direction of the force. So let me draw it like this. So this is the direction of the force. Now another case is, now we reverse the magnetic field. Both these cases will be repeated with reverse magnetic field. So this is N, S, and this is N. So this is N. And we have cross here. Cross means current is going in that direction. So current going in the direction away from us. So in that case, what should I do now? So now N is different. So it should be like this. For that case, if I do like this, it will be a bit difficult. Though it is possible, it's difficult. So what I should be doing like this. This is the magnetic field, N to S, coming to this direction. These fingers are going to that direction, cross. This is the force. Or I can do this in a different way. So I can do like this. I can come to this side, and do like this. See, magnetic field, N to S here, current in this direction, and force in this direction. So in both cases, the force is upward, because only my body is twisted. Whereas I was doing the same thing. So that's why the force is upward here. This is the force. The last case remaining in this condition is, so let me do it as a S. Let me do it as a N. So I should not take more space here because I have to crop it. Then I have the current like this. So this is the current. So what should be like this? So now if I do this side, it will be NS here. Conductor should be allowing current in this direction. So it must be like this. So see, like this. So the force is in downward direction. So NS here, NS, current towards you, and force here. If I again switch to this side, it will be like this. So I am in this side, it should be like this. So the direction of magnetic field in this direction, current towards you, towards the camera, and force downward. So this should be the force in this direction. Let me show it by red. So this is the force. So these are 4 cases, and the 4 cases of such situation in which magnetic field is either in this direction or that direction. Now next 4 cases will be like this. Next 4 cases. So it will be, what happens is magnetic field either downward or upward. Conductor, same case, same condition conductor, but magnetic field will be applied either downward or upward. So let's do it. Let's do it for the magnetic fields acting upward, downward, and current same as before. So here I have the magnetic field. This is N, and this is S. This is the direction of the current. So this is the direction of current. So what happens? So let's see. So this requires that NS downward magnetic field, then the conductor current flowing in this direction, going towards that, and force here. So force will be to the left. So if I come to this side and do, what happens is, if I come this side, it will be like this: magnetic field down, conductor current carrying conductor in that direction, and force should be this. So let me again come here. Come here. This. So in both cases, the force is same towards the left, because these things have not changed. Only my body posture, body orientation has changed, but this thing has not changed. So that's why the force should be towards the left. Next case, a variety of the same thing. The magnetic field remains same. It is NS is same, N and S is same, but the current reverses. That means current is coming towards the camera, towards you. So in that case, what happens is, this is magnetic field NS, current coming towards you, towards the camera, and force in this direction. So it should be the force should be in this direction. It is the force. So more cases. Now the magnetic field will be applied upward. So this should be S. This should be N, and this is the cross I. The next one should be this is S, this is N, and this is dot. Let us see the direction of the currents, direction of the forces. So in this case, NS is upward, NS, current going in that direction. So this means current going in that direction, force should be in this direction, force. So this is the direction of the force. And in this case, magnetic field NS, current coming towards you, force in this direction. So that's why force should be in this direction. This is the force. So 4 more cases. So altogether we now have 8 cases. Now next is so we are going to apply the same type of magnetic field as the first 4 cases. So magnetic field like this. So let me use this thing here. So magnetic field will be, this is N here, this is S here. And now I place the conductor, or I allow current like this. So current is going like this. So this is the conductor. And current going like this. This is I, and this is I. So if so, what should be the force like? So let's see. Current magnetic field here, entry S, current upward, force should be like this. So the force should be going away from you, or the camera, or the observer. So that's why the force should be going to that direction. So I will write it as, so this is the force, this is the force. So next case, like this. So this is N, this is S, and the conductor is like this, conductor, this is I, and this is I. So let's see. So it should be NS here, current going down, force in this direction. So force should be coming towards you, coming towards the camera. So it gives us, so this is the force F, and this is the force F. So it looks like some eyes like that. Again, we have, so I dropped the marker. So again I'll have like this. So this is yes, this is N, then I have got the conductor like this, conductor. This is the conductor, current flowing like this, current flowing like this. The next one is, let me draw the next one also, raw skeleton of yes. This will be N, current carrying conductor like this, so it carries current like this. So this is I and this is I. So let's go for the forces. Now in this case, if I do like this, it will be slightly difficult. So what I do is, I switch to that side, and do it. So let's see here, in this case, NS, it is going towards that direction, current is going upward, so the force is in this direction. So force is towards U, so that's why I must have this condition, F. Again here, I am applying NS like this, and current downward, so force is like this. So force is like this, going in that direction. So the force should be, so this is the force and this is the force. So these are case number 11, 12, case number 9, 10, 11, 12. Now the next 4 cases will be same as above, magnetic field here and conductor like this. So let's apply. So lots of cases here, and I haven't stated right now how many cases. Let's go on, you'll be surprised. So this is the N pole, this is the S pole, and the conductor is like this, conductor, current allowing like this, I. So next is N here, S here, current carrying conductor like this, going like this, The third case is yes, N, current being carried here, I and I. The fourth case will be like S, N, and the current carrying conductor will be carrying current like this. So let's investigate the situation. So here NS is NS down, going downward, current going in this direction, so NS is going downward, current is going in this direction, so force will be towards the board. So it should be, the force should be like this. So in this case, NS, current in this direction, current, and force like this. So force is towards you, towards the camera. So this gives us the force like this. Now here, NS, current here, force here. Simple. So NS, current here, force here. So force should be again the same. And here NS, current this direction, force towards the board, from the camera to the board. So it should be cross. So these are case number, should be it is I think 13, 14, 15, 16. So it's the 16th case. Now again things are remaining. So let's do, things are again remaining. Next 4 cases. For that I'll be drawing the magnetic fields like this. Now the magnetic field will be applied either this direction or this direction, either this way or this way. So it will be, so let me draw it like this, cross. This is the magnetic field, cross and cross, magnetic field, and here I apply current like this. So I can do either way, either this way or that way. First let me do this way. Current is being applied like this. So current. So find the force. Find the direction of force. So it should be like this. Magnetic field being applied here, this is the magnetic field, index finger, current going downward, and force in the right direction. So the force should be in this direction. This is the direction of force. If I do another case, in another case I have got magnetic field still in the same direction, current downward, so upward now it should be, current should be upward. This is I, this is I. So this is B, 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 B. So what should be the force? So magnetic field is still that direction, current upward, force should be like this. So force should be in the direction to the left. So this should be the force. Next case I have got, now magnetic field will be towards the camera or the board or the observer, towards you, B and B. The current will be like this. So this is the current, this is the current. Again here also, let me draw another one also. Magnetic field towards the observer, B. Then this is again B, B, B. And the current is I. Now let's evaluate. Let's go for the answer. So in this case, magnetic field like this towards you, towards the camera, current like this, force like this. See? So the force should be to the left. And then another is magnetic field again like this, current up like this, magnetic field towards you, current up like this, and the force is to the right. So the force is to the right. So these are cases 17, 18, 19 and 20. Now our cases now is from number 21. The same case here, rotated by 90 degrees as we always have had. So in this case I'll have magnetic field same. In the same manner we apply the magnetic field, but this time the conductor will be going like this. This is current I and current I. So again same thing, magnetic field, B, B, B and B, current going like this. Now current going from right to left, I. Now dot, which means magnetic field is coming towards the observer, towards you, towards the board, current going like this. And the last remaining one is dot circle, B, 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 and current going from right to left. So this is the current going from right to left. Let me write I and I. So these are the last 4 cases. So see, nothing is repeated. So in this case what I have is magnetic field going there, away from the observer, current going this direction, current, and force upward. So the force here should be in upward direction. This is the force here. In this case I have to come to this side. So magnetic field here, current going there, so it should be like this, and force in downward direction. So the force should be downward direction. In this case, once again, so I have to do it from this side. Magnetic field like this, magnetic field, current should be like this, current to the right, this direction, current here, magnetic field here, and force downward. So the force should be like this. And in this case, magnetic field here, current here, force upward. So the force should be in upward direction. So this gives the upward direction force, upward direction of force. So these are the 24 cases. 24 cases, possible cases of finding the Lorentz force. And apart from this, there can be only perspective views. So these are direct views. So in direct views, the maximum number of cases is 24. So these are all of those. And when I began my teaching career about 20 years ago, what I did was I did only few of these things, and I assumed that students will do the remaining. But what I found was during exams they could not do that. They could actually perceive that. They could not twist their minds and vision. So that's why since last 7-8 years I have been starting to do all these possible cases, and the results have been fascinating also. I always say in class, if you do mistake in this, that is the worst thing that you can do, that a student can do. So I often threaten also in classroom, you should not be doing like this, and most of the time they do it correctly. Most of the time. I'm not sure about those who didn't say anything to me. Those who have said something to me about the exams, they say that yes, I did that one. So I think if you study all these 24 cases properly, definitely you can solve this thing during exams and at least guarantee 2-3 marks, because that's how this question is asked. So you have to, the diagram is there, you have to go for the force, or maybe if force is given, you have to go for the current, or if you have force and current, you have to go for the magnetic field, and so on. So we have to be very much comfortable. You'll be very much comfortable if you go through this thing totally or completely.